In this lesson, we are going to continue from last lesson about projectiles. So previously, we were working on horizontal projectile. In other words, we are always pushing something off the table, like the previous one. In here, we see a particle off the table, like on the edge of a table, and it being pushed horizontally. Then in the projectile, what we do is the method that we use is called double suvat. So a double suvat you can see in here. So just a reminder, you've got X and you've got Y, and you've got suvat. The first thing that we'll do is A is always 0, and Y, and on the acceleration Y is always 9.8. Now, where there's positive or negative, we'll come back to it later. But then last time, the U is always U. UX is always U, and then UI is always 0, but not this time, okay? So what we're going to learn today is, before we look at double suvat, we first have to look how to resolve speed. Now, this is quite a short chapter, a short skill to learn. So resolving speed, you have learned the word, you have seen the word, and you probably get, this will probably give you a nightmare about resolving from chapter 5 or chapter 7. Resolving speed means putting the speed back to X and back to the Y. So suppose we have a projectile like this, okay, this time we are shooting upwards like a rocket, and come back down. And then we have a U meter per second going upwards that way, and that's a angle theta. So what we can do is we can resolve speed, so which is U meter per second here. Now remember, speed has no direction, so the speed is just pointing one way. Okay, it doesn't tell you which way it's going; it's just one way. Resolve speed into horizontal and vertical components. Now, this is U, and this horizontal will be UX, and this vertical will be UY. So what we can do is, if we draw the triangle out, this triangle, if we make a right angle triangle in here, so we draw it down here. So U meter per second, U meter per second, and then we've got our theta. This will be your UX, and that will be your UY. So using trigonometry, we know cos theta equal UX over U. So if we multiply U across, then UX equals U cos theta, and do the same for UI, and UI will equal U sine theta. Now we're going to put this in our double suvat later, but for today, we're just learning how to break them down. So essentially, that's the main thing about today's lesson. We can break a speed U into UX and UI, and UX will be U cos theta, and UI will be U sine theta. U is the speed, okay? UX and UI is the velocity. Right, one more thing. So, by the way, what you mentioned is the velocity. These are velocity. One more bullet point for speed, which will equal to the speed, which is U, that will equal to the square root of UX squared plus UI squared. All right. Next example, a particle is projected from a point from a horizontal plane with an initial velocity of 40 meters per second and angle alpha above the horizontal, where tan alpha equals 3/4. Find the horizontal and vertical components of the initial velocity. Well, if we're told that's a 40 meters per second, and then we've got our alpha in there, so that will be a UX, that will be UY. So UX equals 40 cos alpha. Now we're told tan alpha equals 3/4. So tan alpha equals 3/4. Two ways you can find alpha. What you can do is, one, the straightforward way is you do inverse tan of 3/4 and then store in a calculator. That will be the best way, I would suggest. Another way, which is students like to do, is what we call 3-4-5 triangle. Now, if you haven't seen this before, I would say, you don't have to learn it, all right? But if you do, I just have to explain once where most students will make mistake, very, very common mistake. I know 10 alpha is 3/4. That means that's a 3/4. That's my 3/5. Therefore, my cos alpha is 4/5. Now, the common mistake is students, when they use the 3/5 triangle, when they want to replace the cos alpha and the sin alpha, so sin alpha is 3/5, they put the 4/5 or the 3/5 into the position of alpha instead of the cos alpha. Now, when you use 4/5 or 3/5, you should replace the whole cos alpha. So what shouldn't happen is I shouldn't see something like this. Sorry, 4/5. Of course. So I shouldn't see something like cos 4/5, and that's not working. Okay, so when you should use 3/5 triangle, you should replace the whole cos alpha. Again, I would personally suggest always using this bit. Okay, if you've got a calculator, why not? All right, store in a calculator. So 40 cos alpha, if you do that in calculator, and you should get 32 meters per second. And if you do uy equals 40 sine alpha, which should give you 24 meters per second. Part B, right? Given that the vectors I and j are unit vectors acting on a vertical plane, horizontally and vertically respectively, express the initial velocity as a vector in terms of I and j. Well, I essentially is the x-axis, j is a vertical y-axis. So the velocity is simply 32i plus 24j meter per second. Right? How do we double check that? Well, double check. Is 32 squared plus 24 squared square root equals 40. Dora the Explorer say yes. So yes, it is. Okay, put in a calculator. Yes, it is. So we know we're right. Example. A particle is projected with velocity u equals 3i plus 5j meter per second. So if I draw a little projectile up, right, 3i plus 5j, what it means is if that's my u meter per second, what I know is this is 3, this is 5, sorry. Thrive, a 3 and a 5 combination combined together, thrive. Yeah, learn that word. 3 and 5, so 3 and 5. Where I and j unit vectors, and find the initial speed of the particle and its angle of projection. So speed, we know speed is the Pythagoras thing, so square root of 3 squared plus 5 squared. Is it 4 squared? It's tempting because we know 3, 4, 5 triangle, but that's not the case, because in order to use 3, 4, 5 triangle, the 5 must be the hypotenuse. So this is not a 3, 4, 5 triangle. Do not do that. 3 squared is 9, 9 plus 25 is 34. So it'll be square root of 34 meter per second. That's a speed. And the angle of projection, is the angle alpha in here. So guess what? 10 alpha equals 5/3. So alpha equals inverse 10 of 5/3, or arc10, more technical version of it, is 59.0 degree around to 3 SF, and that's the answer. Is that it? Yes, that's it for 6.2. A very short one, because this is just preparing you for the monster next chapter.